1, 2, 3, 4, 1, 2, 3, 4. So, whoa, look at that cool picture. Where did I get that picture?
I don't know. Where'd you get it? Google images.
Oh,
3D coordinate system. You find it.
so, I can't really visualize that, but sometimes it looks like it's going in, and sometimes it looks like it's going out. But, yeah, I Googled that. So, sorry. Okay, so for our general purposes, we're going to talk about three-dimensional coordinate systems and vectors. Did we already talk about vectors? Yes. So we're going to talk about vectors in 3 dimensions, and then we're going to talk about the cross product, okay? And we're going to talk about the right-hand rule and the octants. It's kind of hard to visualize here, but so this is a 3-dimensional coordinate system, x-axis, y-axis, and the z-axis is always the vertical axis, okay? So, so the z-axis is always up and down, the x is kind of coming out towards you, and the y is kind of going towards, or like, if you're looking at the whiteboard, this would be kind of the whiteboard plane. This would be kind of the in towards you plane, and this would be kind of the up down plane. When we're talking about planes, okay, this plane, like, can you kind of see that, the one going straight up from the x-axis, okay? This one would be called the xz plane because it's got a component going this way and a component going this way. If I were to draw all the points going straight up, kind of like that, this plane in here would be called the YZ plane. You understand that? Okay. And the other plane, the one on the ground, like this plane over here, this one over here, and it can go forwards and backwards, and just kind of, this one over here, this would be the XY plane. You get that? Maybe. So XY plane is kind of the one that's the floor, right? It's kind of, these things are kind of hard to visualize in 3 dimensions, but this is the XY. This one is the, what did I say, the YZ plane. And this plane is going to be called the XZ plane. So the blue ones are the XZ plane. These ones are the YZ plane going this way. And down here, that's called the XY plane. All right? We use a right-hand 3D coordinate system, and the octants are 1 through 8. 1, 2, I'm not going to, 3, 4, how do you write 5? 5, look, Roman numerals. 6, I'm good at this. 7, is this going to be, it might be. It might say, in which octant would you find this point? So the way you find the octants, you use your right hand, okay? And you rotate around the positive x-axis. So it's really hard to, what? So maybe I could draw this kind of like this. Let me see. Let's see. Can I do this? I don't know. No. No, that doesn't work. So the octants are where everything is positive. That's octant 1. So octant, maybe if I erase all this stuff, you'll be able to see it a little bit. Okay? So octant 1, okay, would be in the x, y, and positive z plane. Let me think. Do you understand? Everything is positive, okay? So, and then you rotate around. So octant 1, if I'm going around this thing, would be kind of front and above. So the first 4 octants, that's a better way to think about it. First 4 octants are above the y plane. Okay, so the first octant would be kind of out here. Second octant, you rotate around. Is that clockwise? Counterclockwise, right? So second octant would be kind of points back here. Third octant would be back here. Fourth octant would be over here. Fifth octant would be those points below the first, right? 6 would be below the second. 7 would be below the third, and 8 would be below the fourth. Yeah? Yeah? Okay. So in space, you can use the three-dimensional distance formula to find points between, find distance between points, just like you can with in the xy plane. And so the way you graph these things, -1, 3, 2, means you go backwards 1, you go over through positive 3, 1, 2, 3, and up 2, 1, 2. So let's pretend that this is point A. Now, in 3 dimensions, it's really hard to see where these points are. But again, the way I got there was going backwards 1, out 3, and then up from that 3, I go up 2 to that point. Done? So I go back, out, and up. Maybe I could draw that. If I draw that, will that look weird? Let me see. Yes?
So the fourth quadrant.
Back, out, and up. What?
Would the eighth octave be under the fourth octave?
Yes, the eighth octave.
That'd be a good way.
Yeah, that's what I said. I did say that. Okay, so there's point A. Point B, I would go out 4, 1, 2, 3, 4. I would go back 2, 1, 2, and then I go up 5, 1, 2, 3, 4, 5. And here's point, oh, that's a cool way to do it, isn't it? Okay, so here's point B up here in red. I said in red. I don't need to make point B dotted, okay? And then I'm going to connect those 2 points, point B, and then I want to find the distance between those 2 points, and I just plug into this formula. So it's just the Pythagorean theorem in 3 dimensions. And so that's going to be, and it doesn't matter which one really you call x2 and x1 because you're squaring them anyway. But x2 minus x1 is 5, right? Squared, plus -2 minus 3, which again is 5 squared, and 5 minus 2 is 3, which is 3 squared, right? Which gives you the square root of 59. Questions on that? Easy enough? Yes, ma'am. Yeah. You just go like this. 1. And different people draw it different ways, but you can just kind of, what's so hard? It's not that. Yeah, it's hard to visualize.
Going up on the z-axis,
Yeah. So z goes up and down, right? X comes out, y goes sideways, and z goes up or down. You'll get it. Okay. Yeah. Okay. Moving on. Moving on to the next thing. What's that? The midpoint formula in space works the same way as the midpoint formula in 2 dimensions. You just take half of x, half of y, and half of z. So let's see if I can draw. No, I won't. Let's go back. No, I can draw it just to show you I can do it. Okay. So I'm going to draw my own 3D plane. Okay. There it is. 1 going this way, 1 going out, and 1 going across. Like that. That's all you have to do. Kind of. Okay. So, so -1, 3, 2, -1, 3, whoops, 3, 2, oh, this is the same point, right? And 4, out 4, back 2, up 5. So here's point A, here's point B, I'm not going to check to see if you graph these totally accurately, but the midpoint would have to be somewhere in between, right? And so the way you find the midpoint, it would be -1 plus 4 divided by 2, comma, 3 plus -2 divided by 2, comma, and 2 plus 5 divided by 2. So that's going to be, what's that? 1.5, comma, 1/2, comma, 3.5. So that'd be your new point, which would be the same as going out 1.5. Who knows where that is? Up 1/2. Oh no, out 1.5, over 1/2, and up 3.5, which would put you exactly there at the midpoint. There it is. There's M. And so such that this piece is congruent to that piece. And it's hanging out there in space. Isn't that cool? It's hard to visualize. That's why they make 3D viewing glasses that you can buy now on Google. You should get some. Hold on. Virtual reality. You should get me some because they're pretty cool.
I can't get myself, so I'm not getting one.
Okay, questions? Oh, I had a graph hiding there. Oh well. So a sphere in 3 dimensions looks much like a circle in 2 dimensions, right? Except you have an H, a K, and then you have Z, they have a J variable. Complete the square to find the center. So you love completing the square, right? So now you can complete the square in 3 dimensions. And so you have x squared minus 2x. I'm going to group all my y, x and y terms together like you do, whoops, when you complete the square. Minus 4, whoops, z squared plus z squared, right? Plus z squared minus 4z. And then I bring my constant term over to here. And then I complete the square, so I get x minus 1 squared plus y plus 3 squared plus z minus 2 squared. But in doing that, I added a bunch of stuff. What did I add? What did I add here? A 1. And here I added a 9, and here I added a 4. Okay? So I get x minus 1 quantity squared plus y plus 3 quantity squared plus z minus 2 quantity squared equals 3 plus 9 is 12 plus 4. So what this would graph is a sphere with the center at 1, comma, -3, comma, 2, and the radius of that sphere would be what? 4. Okay? So that's all there is to that. Sketch the sphere? Right. Okay. You want me to sketch the sphere? I'll sketch the sphere.
Can we do our like matches? That's easier to draw.
Can you do what? This?
Yeah.
Sure, but then it's harder to see the negative points. You know, this is just the first octave.
Yeah, but if you can draw it.
Yeah, that's fine. Okay? So,
Wait, what? Wait, no.
What?
Why isn't the positive x is coming this way? Why isn't it the positive x is going that way?
Oh, that's
what do you mean?
Well, like, when you draw an x, y,
X and Y are switched.
What?
X and Y are switched in computer. But that's okay.
Oh, wait. Is that different than what I showed you on the last?
No, it's not. It's the same, but it's like.
But like if you take a regular XY axis, like make it flat, it should be like
It just says positive comes towards you.
Yeah, X, Y, Z. Because they have to put that third dimension somewhere, right? So,
why don't they just put it in the
can we stop all the yakking? Okay. So 1, -3, 2 would be out 1, back 3, up 2. And then you would take your tool box, and you would sketch in a sphere. How do I do a sphere? Like this. And then you take your ellipse tool, and you go like this. And then you make it dotted. And then you can make a pretty cool sphere, I think. Just showing that if I drag this down there. Not that. Oh, they're connected. You get the idea, right? It's not, I'm not going to grade you on your sketches, okay? Or anything like that. All right. Next thing is called a. Any questions on that? Go back. There you go. It looks like the Earth hanging out there in space. X, Y, Z. Just the way it works. H, J, K. Can I move on now? Only one more thing, really, and then we're done. Okay. So the next thing is called. This is called a surface in space. Let me graph that. The sphere is called a surface. And then the intersection of a surface with one of the 3D coordinate planes or with a plane parallel to one of the 3 coordinate planes is called a trace. And that's like a slice in space, okay? So describe and sketch the trace of the sphere with the equation xz trace. Okay, so what that means is that this sphere, okay, is cut by this plane, which is the x. So this is going to be fun for me to sketch, okay? So I'm going to go out 4, 1, 2, 3, 4, right? I'm going to go back 3, 1, 2, 3, 1, 2, 3, and I'm going to go up 1, okay? And I'm going to sketch a sphere that has a radius of what? 5. Okay, so I'm going to, where's my sphere tool? This, I don't want this. I want this radius of 5. So I'm going to try to sketch a sphere. I'm going to get this, I'm going to try this again. Okay, if I start here, there we go. You get the idea, right? So now, if I were to find the trace of that, that means if I took this thing and used the XZ plane as like a cheese slicer, what shape would I get? You get, not a semicircle, you get a circle, right? Right? If I,
When you get started.
Oh, like what you see on the
Is the
inside?
right, you know, if they take like the cheese slicer, if
Is
it's,
the XZ this one or is
the,
it
this
this one?
is the XZ, right? XZ plane is the one going this way,
I mean,
right?
it doesn't matter either
Right.
way because it's a circle. So
Yeah, you get a cross section of a circle.
So you would get a cross section of the circle. Does everyone see that? Okay. And so describe and sketch the XZ trace. The way you find out what that equation is by plugging in what's the y coordinate in the XZ plane? 0. So you plug in 0 where you see a y, right? Do you understand that? Because the y coordinate is 0. And so you're going to go x minus 4 squared plus 9 plus z minus 1 squared equals 25. And then I subtract 9 from both sides, so I get x minus 4 squared plus z minus 1 squared equals what? 16. Subtracted 9 from both sides, which is another circle with it, which is a circle with its center at 4, comma, it's 4, the coordinates of the center of that circle in 3 dimensions would be 4, 0, 1.
So that's just a circle on a 2D.
That's just a circle. But, and what's its radius? 4. So if I go out 4 over 0 and up 1, okay? Ooh, that's kind of weird. I get a, this is really hard to do, but I get a circular trace, okay? It's a circle kind of in here, right? Trace would be something like that in that plane. You understand? No? It's if I took this ball of cheese and put it into the cheese slicer, which is the XZ plane, I get a circle, and the center of that circle would be at 401. Okay? It's not that bad, huh? And so this is the trace of that. Be a circle. What?
How do you know that y equals 0?
Because if it's in the y, excuse me,
Oh, if it's an x, y.
it's in the XE plane, the y coordinate is here. Okay? And that's all there is to it. You could do that, right? It's not impossible, not hard. Okay? And I think that's the end. Homework. Fantastic.
That means there are only 4 questions.
That means there's only 4 homework questions.
No.
No. You can start now.
Mr. Leader,
Yes?
back to the last slide.
Can I go back to the last slide? Yes.
That's the one for that. 1 second.
Are we done?
We're done?
That was not bad.
I told you.